Have you ever looked at a brush motor and wondered what is inside? Well, you're in luck. Today's video is motor parts. I'm John Holmes. Stay tuned. Today's video is going to be over the brushed motors. We have done this in the past, but we figured we'd do it again. It's always good to have a refresher and maybe get a little bit more information in there. So essentially what I'm going to do today is take apart a brush motor, tell you what the parts are as I take them apart, and tell you what they do. So let's just get into it. What I'm going to do is start with taking apart a Crawlmaster Pro 540, and I believe this one is a 16 turn. So let's just get into it. This particular motor uses a Phillips head screwdriver, so as usual we're going to find the largest Phillips head screwdriver that we can. This is a number 1, which fits perfectly into the screws. And we've got these two little screws on the endbell. There's your first term, endbell. And what we want to do is just loosen those a little bit. But before we take the endbell off, we have to take off the springs. And you can see here, we have a spring on each side, the positive and the negative, denoted by having a red and a black on each side. Not all motors are like that, but a lot of them do have either a red and a black or silver and a black to denote your positive and negative. So we take off our springs first on this rebuildable motor. Make sure that our brushes are not jammed up in there, and at this point we can rotate our end bell on the can and then pop it right off. Inside there are going to be the washers or shims. Technically they're shims because they're used to shim the shaft on the inside. But we're going to take those out so that we don't lose them during the process. And now we can take our armature out. Typically you never want to touch the commutator portion with your fingers, but since I'm doing this for a video, I'm going to touch it there so I can pull it out. And on the bottom inside is going to be another one of those shims. Make sure you don't lose that. Now the parts of a brush motor are going to be the same no matter what type it is really. So this rebuildable style that we see here, this is a Trailmaster Sport. It has all the same parts inside, but since it's not a rebuildable motor, we can't take it apart and look at it like this and spread it out. So for this video, I'm choosing the rebuildable just because it's easier to see the different parts. So this is our rotor. The rotor consists of a lot of different sub-assemblies. For now, I'm going to set that aside. These would all be considered rotors in a non-finished or finished state. This portion can just be considered the housing. So that's what the rotor sits in, and that's kind of typical on pretty much all motors. The rotor goes to the inside of the housing, but the housing is made up of more smaller parts. So we have, when we take it apart, the can, and then also the end bell. Inside the can, we have our bearing, of course. The bearing is what the shaft of the rotor rides in. And then we also have the magnets. And these magnets are an FB9 ferrite from TDK, if you're interested in knowing. And then on the end bell, we also have many smaller parts. We have the brushes that go into the brush channel on this particular design. We had the springs that push the brushes onto the commutator. And then we also have the various other smaller parts that kind of hold it together. This would be what's considered a timing ring on our rebuildable motor, and then the two screws that I loosened up at first go into the timing ring. You don't have to take those completely out to get the motor apart, as I showed. Some people like to do that. I think it's a little bit more difficult to put it back together that way. And then, of course, we also have a bearing on the top side, right here, that the shaft of the rotor will ride in. You can see these end bell parts taken off of the plastic. The sub brush assembly or the sub channel, the main brush channel, the brush by itself with a little eyelet on this particular one. You can solder the brush on or you can bolt it on. And then the actual spring itself. Now let's go to the rotor. The rotor is also made up of many smaller parts. Of course we have the copper wire, which is wrapped around the lobes of this part. The metal part, which a lot of times is insulated in a green powder coat, is considered the stator. So the wire is wrapped around the stator. The stator is then affixed to the motor shaft, which goes into the bearing so that it can spin freely. And the copper wire is also terminated onto what is called the commutator. The brushes ride on the commutator, and this is how we get the forward locomotion of a brushed motor. You have a north and a south, or a positive and a negative, And when they energize these coils, you essentially will get a north side and a south side. It's not a perfectly left and right relationship because in most cases on a brush motor, you will have an odd number of slots on the stator. But that's kind of in depth and we don't have to talk about that today. Really, the basics that you need to know is that you have brushes, they ride on the commutator, and they energize the coils, and that's how you get the forward motion of a brushed motor. Now, when we get down to it, though, there are a lot of small variations that there might be, and that is where, say, a rebuildable style has higher quality than a non-rebuildable style, in that it'll have better quality laminations on the stator. So these are made up of a lot of little thin pieces of steel, a silicon steel that is used for electrical, the same as you would have in other electrical appliances, other electrical motors that you may have around your house. They're all made of laminations, and that's to keep the losses down, which maybe we'll cover that in a different video. But these are all laminated steel stacks essentially pressed in. And when you get into lower cost motors, the laminations themselves are going to be cheaper. The magnets themselves are going to be cheaper and typically a lower force to them or a lower temperature rating. There's a lot of different ways that you can increase the quality of a magnet. But essentially, as you get into a more expensive motor, they will generally have more expensive parts inside. So as we can see here, we have our ceramic magnets on this. I do make motors that have neodymium magnets in them, and this is one of them. This is our Puller 500 series, and it fits the same armature or rotor, as it may be called. So this would go into a 540 can, as you saw me take apart. But this rotor or armature also fits into the Puller 500 housing. But as you can see, it's a smaller motor, or at least the housing is smaller. And the reason for that is that I use higher strength magnets, neodymium, NEH35 on this particular one. And when they're stronger, you can actually get away with essentially less magnet for the same force. And that allows us to make it a smaller motor, a smaller diameter of motor, and also drop off some weight. And on average, we drop about 1 ounce off the motor. So we go from about a 6-ounce motor to a 5-ounce motor by using higher quality materials on that. But they're still the same when it boils down to it. All the parts of the motors are still the same. This is still a housing. It still has magnets inside. It still has bearings inside. And so we can really, they're stronger magnets. They're definitely stronger magnets. I'm gonna have to get some help. There we go. So, as I said, stronger magnets in the Puller housing. And then if we look at the endbell also has all of the same parts. We have our upper and lower brush hoods or brush channel. We have the gold brush channel and the orange lower hood on here. We have our spring perches, which the springs sit on. Those would be here on the normal rebuildable style, the 540. And then on our Puller 500, those two little guys, it's the same thing. And the brushes insert into the brush channel, all the same. If I can get it. There we go. So really the point is that a motor may have different construction styles to them, but it's really the same. And if we go one step further, we're going to take a look at the inside of this non-rebuildable motor, this Trailmaster Sport. And you can kind of see that we have the brushes riding on the commutator. Here, I'll spin this, and you can see the commutator spinning past. And the brushes ride on it all the same. But instead of having the typical spring, we just have a piece of metal, a piece of flat metal that acts at the spring, and so we don't actually have the brush channels. That is lacking on this particular non-rebuildable design. But inside the can, there are the magnets all the same, and they're a lower quality than our rebuildable style that we have, a little bit less coefficient of force. But otherwise, it's the same. We have this particular one does not have a face bearing. The ones that we have now do have face bearings. And then a bushing on the back that needs periodic lubrication. But really, when it boils down to it, the parts are still all the same. We have a housing. We have what could be considered an end bell that gets pressed on in a non-serviceable manner. We still have the rotor or the armature, which has the copper wires wrapped around the laminations. We still have all the other parts that I could go through yet one more time. Now, I would like to talk about the rotors themselves, or the armatures themselves. And as you can see between these two, maybe I'll pick up the Magnum rotors. The Magnums have a larger diameter to them. And instead of using the thicker magnets, the thicker FB9 magnets that we would typically use, what we do is we throw the thinner neodymium magnets inside so that we can fit a larger rotor inside the same size can, and we can actually get more torque from that. Because torque is a relation to the square of the radius of a rotor, and you add some radius to a rotor and you get more torque output. So it's kind of a nice relationship. But as we can see, there are 3 segments to this armature, and there are 5 segments to this armature, and those are typically called slots. In some other countries they call them poles, but in the US we typically go by magnetic poles, and then the steel are the slot count. So we have the 5 slot, we have the 3 slot, and there are other choices in the market. Well, there used to be, not anymore really, but you can make a motor with 7 slots, with 9 slots, and typically it's always going to be an odd count, and that's a little bit more in depth on why it's an odd count for a brushed motor. But for the most part, it's always going to be an odd count on there. And we even have these already wound up, so you can see that the winding style is a little bit different too. The 3 slot takes a nice pattern wind. It packs in a little bit more copper, a little easier, and it will typically have a torque advantage. And that's why we call our Torque Master line the Torque Master, because it's a 3 slot and it has a little bit better torque density. On the 5 slot, it's not nice and pattern wound, but we can still fit in a good bit of copper. And the effect of this particular one, and this isn't exactly related to the 5 slot versus the 3 slot, but it's the way that I design them, is that the 5 slot starts up smoother. The 3 slot makes more torque, the 5 slot starts up smoother, so we call the 5 slot the Crawl Master version. And they're really the same when it boils down to it as far as all the other parts, but they feel different when you drive. And that's why that there's a variation to the market. That you can get away with a non-rebuildable style, but you want it to feel a little bit more powerful. And so that's why you would go with a hand wound or a rebuildable style, because the quality of materials is higher and it ends up feeling better when you're driving. And some people do value that. Or maybe you want more torque for towing behind you or something. You're going to use the rig for towing, and so you use a 3 slot armature. Or you would even go to a longer armature. And the length of the armature does affect the torque as well. If you have an armature that's twice as long, you can essentially make twice the torque because you have twice as much active materials inside of the motor. So it's a nice, easy relationship on that. But the take home is that if you want more power or if you want more torque on a motor, you essentially just size the motor up. And it's as simple as that. Now there are, of course, construction differences that make a difference in the quality of the motor that may affect the torque or the power, but that's more of a finer detail, and it's a lot easier to just say to yourself, hey, I want more power, can I fit a bigger motor? And if so, then do it, essentially. So I really think that that covers all of the basic parts, and I'll just put the motor back together to show you. So we have our armature, or our rotor, with all of the subparts that make it. It needs a shim on the bottom for this one. When you take a motor apart, it's always good to shim it back in the way that you found it. The shaft of my armature will go through the bearing on the face of the can. And then we will put on our shims on the top in the order that we found them. And now we can put our endbell back onto the housing. Once we have our endbell installed, in the timing that we wish, and to be consistent, I'm going to do it for forward rotation, which I might as well mention. If you want to reverse the rotation of your brushed motor, you can either spin your endbell in 180 degrees if it's a rebuildable, or you can just change your wires, flip your wires around. So have your positive go to the negative and the negative go to the positive, and that will also reverse the orientation of it. Or in a lot of ESCs, you can actually do that. Inside the ESC programming, you can change it from forward to reverse as well. A lot of different ways to do it. None of them are wrong. And again, with the longest screwdriver that you can find to make your life difficult, we just barely tightened this down. We wanted to make sure it's snug, but if we tighten too much, it's going to bend the timing ring on the inside. So don't do that. That's good for nobody. And then lastly, we install the brushes back onto the motor. I'm sorry, the springs. We install the springs onto the brushes that I have already put back into the motor. And now we have a fully functioning motor again. And that's all the parts. If you do have any questions about parts, maybe I missed something on there, or if you have more in-depth questions that you would like to see in other videos, feel free to comment down below. Let us know what you'd like to see. Hopefully this helps you out on all the parts of a brush motor, helps you understand how they go together and make a motor that works. And if you have to take apart a motor yourself, hopefully it'll help you figure out how to do it and put it back together properly. So thanks for tuning in today. Again, I'm John Holmes with Holmes Hobbies. Have a good one.
Nice.
Still got your redneck roadkill shirt on, or realized that halfway through when you were talking about Holmes Hobbies.